Hey guys, welcome back to our channel. Thank you for joining us today. Today we will be speaking about NASA's astronomers find two giant black holes spiraling toward a collision. Please watch the entire video to find out all the details. And guys, don't forget to like, share, subscribe and click the bell notification. Alright then, let's get started. A supermassive black hole 9 billion light-years away seemed to have a sidekick black hole circling it. As the orbit recoils, the pair draws nearer to combining. Supermassive black holes millions to billions of times the mass of our Sun lie at the core of most worlds, and space experts are anxious to know how these behemoths became. While they think it generally came about because of no less than one consolidation between two or more modest supermassive black holes, researchers are short on perceptions that could give knowledge. Since only one set of supermassive black holes en route to a consolidation has been found. Another review might change that. Researchers noticing a supermassive black hole report signs that it has an intently circling sidekick. The enormous duo termed a binary circles one another every 2 years. Assuming the group is correct, the measurement of the twofold circle is 10 to multiple times less than the central other known supermassive double, and the pair will converge in about 10,000 years. That could appear to be quite a while. However, it would take around 100 million years for black holes of this size to start circling each other meet up. Thus, this pair is almost 100% of the way to an impact. Joseph Lazio and Michel Vallisneri at NASA's laboratory in Southern California understood how supermassive black holes act in a paired framework and how to decipher the radio information. Proof that this supermassive black hole might have a sidekick comes from perceptions by radio telescopes on Earth. Black holes don't radiate light, yet their gravity can accumulate plates of hot gas around them and launch a portion of that material into space. These planes can extend for a great many light years. A stream highlighted Earth shows up far more splendid than a fly pointed away from Earth. Cosmologists call supermassive black holes with jets situated toward Earth blazars, and a blazar named PKS 2131021 is at the core of this new paper. Situated around 9 billion light-years from Earth, PKS 2131021 is one of 1,800 blazars that a gathering of scientists at Caltech in Pasadena has been checking with the Owens Valley Radio Observatory in Northern California for a long time as a feature of a comprehensive investigation of blazar conduct. Be that as it may, this specific blazar displays a peculiar behavior. Its splendor shows average highs and lows as typically as the ticking of a clock. PKS 2131021 is a unique sort of black hole known as a blazar, fundamentally a supermassive black hole pointing a flyer of the supercharged matter straightforwardly at Earth. That matter starts from the rings of hot gas that structure around specific black holes. When a black hole attracts that gas with its intense gravity, some concern might get away instead of being pushed out in a stream of plasma going at almost the speed of light. Specialists think this standard variety is the after effect of a subsequent black hole pulling on the first as they circle each other like clockwork. Every one of the two black holes in PKS 2131021 is assessed to be 200 or 300 million times the mass of our Sun. Researchers will attempt to identify gravitational waves, swells in space coming from the framework to affirm the finding. The prominent recognition of gravitational waves from black hole pairs was reported in 2016. Thus, the specialists dove into information from 5 observatories spreading over 45 years. The extra information matched the group's forecasts for how the twofold blazar's brilliance ought to change after some time. To affirm that the motions weren't arbitrary or the reason for an impermanent impact around the black hole, the group needed to look past the 10 years, 2008 to 2019, of the Owens Valley Observatory information. In the wake of discovering that the 2 other radio telescopes had likewise concentrated on this framework, the University of Michigan Radio Observatory 1980 to 2012 and the Haystack Observatory 1975 to 1983, they dove into the extra information. They observed that it matched forecasts for how the blazar's splendor ought to change over the long run. This work demonstrates the significance of persistence, said Lazio. It required 45 years of radio perceptions to create this outcome. At various observatories the nation over, little groups took information all day, every day, throughout every month to make this conceivable. Assuming that the discoveries are affirmed, PKS 2131-021 would be the second set of parallel black holes at any point found and the most impenetrable super researchers have found. Researchers found the universe initially knew black holes as a dual competitor in 2020 in a cosmic system around 3.5 billion light-years from Earth. Nonetheless, those black holes circle each other like clockwork, proposing a more prominent distance between them than between the two individuals from PKS 2131-021. The two B's black holes are adequately enormous and close to an adequate number that they could release gravitational waves ahead of their unavoidable impact, the review creator said in an explanation. Future perceptions of PKS 2131-021 will zero in on getting those waves in the demonstration. The scientists say that every one of the black holes distinguished in this study has a mass adding up to countless times more than our Sun. It required around 100 million years for the two items to combine on their circle, which has them a good way off of multiple times that isolating our Sun and Pluto, NASA said. The office said the two black holes are over close to 100% of the way toward impacting. Researchers have found that the most enormous systems contain a supermassive black hole. Stargazers don't have the foggiest idea how these items became so huge. Yet, one chance is that the universe's biggest black holes result from somewhere around one consolidation between two more modest black holes, as per NASA, composed Brandon Spector on the Live Science News site. The new review might assist with affirming that theory. The Caltech research group ran over this intriguing instance of a parallel, the term for two major black holes circling each other while concentrating on quasars. Quasars emerge at the focal point of a system where gravity is maneuvering matter into a black hole. Yet, a few particles escape and are discarded at practically the speed of light. That fly of particles is a quasar. Quasars with molecule jets pointed straightforwardly at the Earth are incredibly brilliant and called blazars. While contemplating around 1800 blazars involving the Owens Valley Radio Observatory in Northern California, the researchers saw the specific blazar, named PKS 2131-021, had a standard example of radio frequencies, electromagnetic waves we can't see, however, can be estimated by radio telescopes. That drove them to gander at the quasar's movement caught over a long time from other telescopes across the world and NASA's Wide Field Infrared Survey Explorer space satellite. Whenever we understood that the pinnacles and box of the light Ben recognized from ongoing times matched the pinnacles and box saw somewhere in the range of 1975 and 1983, we knew something extremely exceptional was going on, said Sandra O'Neill, lead creator of the new review and a Caltech undergrad understudy, is a depiction of the exploration on the college's site. The standard radio frequency variance is similar to the ticking of a clock, emphatically proposes that this blazar harbors not one supermassive black hole but two supermassive black holes circling one another, Redhead said in the exploration portrayal. The scientists say it is just the second set of circling black holes distinguished by researchers. Space-time undulations from gravitational waves made by two impacting black holes 1.3 billion light-years away were kept in 2015 by the National Science Foundation Laser Interferometer Gravitational Wave Observatory. As these two most as of late found black holes drawn nearer to one another, they will ship off ever bigger gravitational waves. The Caltech group is attempting to identify these waves in the space-time continuum. As a result of the speed of light, what the researchers are recording has previously occurred, so the genuine impact occurred just shy of 9 billion years prior. However, we will not have the option to see it on Earth for a very long time, Red had said. Meanwhile, those waves will upset reality, as Einstein anticipated over 100 years prior within his hypothesis of relativity. Yet, when they hit our world and Earth, they represent no risk, nor does the impact of the black holes. The gravitational waves are basically swells in reality, he said. These two supermassive black holes are up until this point away from that. We won't need to stress over any impacts from the consolidation, and as a rule, the size of the gravitational waves is still little to such an extent that we don't need to stress. Joseph Lazio, a co-creator on the paper and boss researchers of the Interplanetary Network Directorate at the Jet Propulsion Laboratory at the California Institute of Technology, told USA Today through email. Well, that's all we have today. If you enjoyed today's video, don't forget to like, share, and subscribe.